Hello, everybody. This is Troy Gabel. I am the Chief Revenue Officer for Next DLP. Thank you for joining us today. Today's topic for the Fireside Chat is a webinar around machine learning. Before I get into the machine learning aspects of it, I am a less technical presenter or conversant on machine learning. I've invited Alan to join us today. Alan, maybe just give us a quick introduction before we jump into what is machine learning in a next world.
Sure. Well, hello, everyone. My name's Alan. I'm the technical lead for what we would call the agent team, which is our endpoint client software here at Next. So yeah, we kind of do all the monitoring software that forms part of the solution. And, today we're going to talk about how we can use machine learning techniques in that part of the system to improve the detection rate, the accuracy of the information that we can provide there.
Let's talk a smidge about machine learning, because I think when you stop and think about the term, it is a buzzword that a lot of people are throwing around these days. And they're coupling it with other terms like AI and artificial intelligence, which in our world, we separate those two things, I think, pretty distinctly. We're focused really on machine learning. But in a Next DLP world, machine learning to us is slightly different, or maybe it's more focused than some of the machine learnings across the world. So to us, machine learning is a way to enhance our capabilities around protecting data within the organization. We have taken the machine learning, the models, if you will, the signals, the correlation of data in succession, and we put it down onto the endpoint, and we've let every endpoint become its own individual machine learning engine. So when you think about the visibility, and I won't steal your thunder, but when you think about the visibility that everybody talks about, and we think our visibility is second to none, you can take that visibility, but most data protection platforms stop there, and they rely on the people that are looking at it, the incident responders or the data analysts, to go and make heads nor tails of it. What we've done is we've turned every endpoint into a machine learning engine that, after about a few weeks, again, without the need to create a bunch of policies, so in a policy-free world, we've created the endpoint's ability to show anomalous behavior. I'll use a quick example, and then I'll let you talk about how we do it. But that example might be a series of events rather than isolated incidents. Machine learning incidents by itself, so each individual thing by itself is really just going to create much noise inside the system when we send those alerts back up to the detections, as we like to call them, back up to the environment in the cloud, to the SaaS solution. We don't want to be creating false positive 2.0, right? I mean, we're just getting away from everybody's fatigue with false positives. What we've done is we've taken machine learning and we've created these models that are combined. So, for example, great use case. I may have logged into a system 10 times and on the 11th system got my password correctly. Individually, that might be scary to somebody, but it's really not something that we should bubble up. But if I combine those things with the rate at which I typed those passwords, and again, maybe 10 failures in an 11th plus the rate is not enough, but then it goes to a destination that I've never been, from an application that I've never used before, the consolidation and combination of each of those insulated incidents or insulated events in my system, when you put them together, raise an alert and send it up to the cloud. And to me, that's the power of machine learning. There was no policy there. It was just, those are atypical behaviors that when you put them all together, start to paint a picture that we've gotten really good at identifying and saying somebody somewhere should look about this. So I don't know how we do that. I know that we have these models, but maybe I'll pause there. Alan, talk to me a little bit about how do we do that?
Yeah, I suppose just to go back up to exactly what machine learning is. I mean, I think your comment about it being conflated with artificial intelligence, and it's from an academic standpoint, that's part of the research that goes on there. But really, what machine learning is a set of algorithms and techniques which are very good when given large volumes of data, of extracting patterns and useful information. So they're a kind of filtering or distillation mechanism when it comes right down to it. And you mentioned the issues around false positives and having to have large numbers of people to wade through all of the data that cybersecurity products can create out there. And this is where machine learning can be useful, right? So we've got all this monitoring information, but we want to find out the signals inside that data and extract those and use those to provide actionable information to our customers. So So yeah, that's kind of the first part of that discussion. There is kind of what is actually machine learning. What does it actually do inside our system?
We talk a little bit about the fact that we've pushed it down to the endpoint, and I think when you stop and think about most machine learnings, I don't know how unique we are, but I tell everybody we're the only one doing it, and I believe that to be true. When we think about machine learning, most of the data cybersecurity tools in the world today are collecting data in the cloud. They're using it across these large cohorts. How are we doing it different? What's different or uncommon about the way we're doing machine learning?
Yeah, so well, as you kind of point out, right, machine learning, if it's happening right at the endpoint, that means it's looking at the individual data that's coming from that endpoint, coming from that specific user, and tailoring those models to that behavior in particular. And that means that we're more likely to get more accurate outputs basically from that machine learning. So, it's quite likely that I don't know, someone who works in your finance department has quite different activity from someone who works as a software engineer or works in sales and marketing or whatever branch of your organization that happens to be. So the doing it at the endpoint means that it's a much more tailored output. The other thing that's pretty good about doing it at the endpoint is that, as I sort of said before, all of these techniques are designed to take very large amounts of data and basically filter out the most important parts. So it's pretty sensitive, right? It's giving you lots of information about an individual or a small set of individuals who use a computer, what's interesting about their activity. So by performing the learning on the endpoint and keeping that data there, we're not taking any risks about how that data is transmitted from the endpoint to some infrastructure, or how well that infrastructure is secured. We've got it all locally and it stays on device.
Alan, I know that we talk about machine learning on the endpoint because it's unique to us. I still think that there's some value in having machine learning done maybe at a metadata level, maybe not at the individual component level, but at a broader scale. In the cloud as well, right? In the SaaS environment. Talk a little bit about how we're doing, yes, the machine learning in the cloud, but maybe we're also adding some flavors of that to round it out in the cloud. Are we doing anything in the environment on the back end on the whole of the data that we're collecting?
Yeah, I mean, I think it's important to mention that there's machine learning on the endpoint, but you can also do it on the infrastructure side as well. And both have their place. Both are useful and carry different risks in terms of where that data is moving to and how we're handling it. Obviously, machine learning on the endpoint, the information that we're going to be able to derive from the models is highly personalized to that individual user. And as we kind of discussed, there are these advantages of being able to use that data immediately and it being continuously altered. The great thing about doing certain machine learning on the infrastructure side, though, of course, is that you can compare different users. So there might be different groups inside your organization. As I said before, you might have, your finance organization, your marketing organization, your sales organization. In our case, we have a software engineering organization whose habits and computer usage deviate quite significantly from everybody else, I imagine. So we look for some patterns in these groups, and that gives us a view over all of that. So for example, we might look at patterns in DNS name resolutions. In other words, kind of what websites or what network connections these systems are making, and that can be more useful at a higher level. Whereas and work in consort with the data that's gathered at the endpoint.
I guess it's important to note too that even on the endpoint, the models are not. I mean, while they're static, they're tunable as well, right? You can increase signals, you can change those signals. So if we saw some sort of cohort behavior within the engineering organization, we could also tune those models down to the individual from what we see in the cloud to make the endpoint models even better. Is that a good summary of what you were saying there as well?
Yeah, so in our system, the machine learning is used in concert with the policy configuration. So you're kind of able to be less specific in your policy configuration and just kind of ask the system to find, a useful or interesting trigger, or when things change, when they're not doing what they normally do, perform this action, take this
Look
action.
under this rock. Look under that rock.
Yeah, exactly.
Tell me what you see. The other interesting thing I find behind that is I travel a lot internationally. I'm headed to South Africa in the end of March. I'll be on a plane for 21 hours. There's a point of risk in that in people that travel. And if the machine learning is running on the endpoint, it's not like it goes away when I fire up my laptop off any network, right? Those machine learning, those models are still continuing. I'm still getting both the analysis of learning normal behavior, but the ability to do something about it or raise an alert. Maybe not necessarily on the spot, like maybe not until I hit the ground in South Africa and it, attached to a Starbucks network, but it's still going to be there. It's still going to be identifying those types of risks.
Yeah, exactly. I mean, I think that's a really key point. So one of the ways that all of these techniques and of modeling user behavior works is it's important to understand that it's a continuous analysis of user behavior and all of the activity that they perform. So as I say, or as you say, the ability to do it on the endpoint means that analysis can be ongoing, the baseline itself that we're measuring against. So in a lot of cases, this machine learning allows us to tease out this normal behavior pattern. And then what we're looking for, what products that do this look for, is deviations from that pattern. So, as you said, normally you log in first time and you type in this particular way with these particular keystroke patterns, but suddenly that all changes, and that's a bit suspicious. Perhaps we want to indicate to someone that that's worth a look. But the ability to continuously adjust that baseline without having to transmit to remote infrastructure means that we can take action on that information on the endpoint autonomously without needing to worry about that. So for example, in your example about being on an aircraft, that baseline where you're cut off from the network, the remote network there, that baseline is continuously being adjusted. So if you left your laptop on the tray table and got up to go to the bathroom or take a walk or something like that, and someone sat down and used your laptop, then the keystroke monitoring, for example, should notice the deviation in your typing pattern, and local policy can take action right there and then to perhaps lock the session or use some other action that might be present on that endpoint to limit the damage they might cause. So yeah.
What are some of the, I'll call them triggers, I don't know if that's the right word or not, but signals, or what would be 5 or so unique triggers to the platform?
Yeah, so you might use all sorts of things really, but in our case, we kind of tend to look at things like, if you're downloading a file through a web browser, we might look at the size of that file, and we might look at that, in aggregate. So it tends to be that, you download files that are on or about some particular size range, but then if you step outside that by a wide margin, that's kind of interesting. We also can look at things, we kind of touched on this before, but we can look at things like your typing patterns, how an individual reaches across the keyboard. I think we all know someone that we look at using a computer and kind of in horror at their approach to finding whatever letter on the keyboard
they want. Talk about that, man.
But everyone's got their own way. We can't all be Mavis Beacon. I'm not sure I'm allowed to say that if it's trademarked, but here we go. So yeah, all of these individual signals that we can look at. And then the other interesting thing about machine learning in general is that we can start to combine these together. And that can be very powerful as well as this compositional effect. To say that, the user is performing activity that's different, and they're also, doing it in a different way. And that allows us to kind of bring forward that idea of something odd happening, but not just looking at a single channel of events.
Behavior and the context of that behavior at the same time.
Exactly that.
Interesting. Talk to me a little bit about education. So cyber education, and I don't want to deviate from machine learning, but can we use the machine learning to do things? I know that, I had to go take an hour-long training course when I came to the company around my cyber hygiene and how I need to be careful with the data. I think it's important to talk about not just raising awareness and insight, but taking action is important as a follow-up, whether we're stopping somebody from doing something or creating that belief, but what are some of the actionable insights that we can get out of this, and maybe cover a little bit around some of the cyber education, because I think that's an interesting point to keeping people to doing what they're doing.
Yeah, absolutely. So one of the things that we find customers in general, I think, really enjoy is exactly that education facility inside our product. Certainly, a lot of it is to do with where your information, where your data is going. So for example, if if it's not normal for you to upload things to a particular cloud provider's storage, perhaps your company has policy that encourages you to use one in particular, or you're discouraged, for example, from sending sensitive or lots of high volumes of documents via email attachments. The company would prefer you to use another route for that. Yeah, these are the kind of deviations from the norm that we can trigger on, and more than that, like it's important sometimes just to kind of nudge a user in the right direction. So it's not necessarily the case that they're doing anything wrong. In fact, their behavior might well be legitimate, but it's useful to kind of present them with information about why what they're doing might not be what they intend, or what's good cyber hygiene, right? You're kind of perhaps taking a risk here that you don't need to take, and maybe you should think about your behavior, but rather than bringing the shutters down on the computer or locking it up, or kind of preventing you from continuing down that path.
We could absolutely shut it down, but there are better ways to.
Oh, we can. Yeah.
Happy. It's interesting to me. It's like cyber awareness training at the point of risk, rather than making me take an hour-long training class and then require me to remember what I'm doing a month later in practice. It gives the cyber awareness team, if there is a separate team, at least a cybersecurity team or whoever's responsible for it, the ability to interact with the user at the point of risky behavior. I think that coupled with this machine learning gives you a really powerful story, because not everybody's creating risk in the same way. In fact, every machine is probably doing a little bit differently, and to be able to tap into some of that, maybe even replace cyber awareness programs that are built in a in a box, so to speak, and taking that to the user, I think is a really interesting concept that I think you're starting to see more and more of, kind of awareness at the point of risk.
I agree, and it's one of those things where if you can get the user, the user of your system online, so this is the person who sits in front of the laptop who's that the agent is running on, if you can kind of bring them in and partner with them to improve cyber hygiene, then that's a really powerful thing, because then they're working with you rather than against you. The system is there to help them learn and remind them of what they're doing. So
makes sense. Talk to me for just a few more minutes around maybe machine learning and the misconceptions. Is machine learning going to solve the world's problems for us? I mean, is that the next? We're never going to create another policy again. I mean, what are some of the misconceptions that you see with machine learning? And I'll share what I think after that.
I think it's a really important part of the discussion, actually. So machine learning, as I sort of said earlier, it's a set of techniques that are able to tease out useful information from very large volumes of data. It's just what it's actually going to do is lighten the configuration load that we have. So in a lot of cases, you need to sit and configure policies that look for specific data. You have to explain to a DLP solution or a cybersecurity solution what specific data is sensitive and where it should go, and what should be allowed, what should be allowed to happen to it inside your organization. So machine learning can assist with the burdensome nature of that configuration. You might not have to be quite so specific all the time, but it's still going to be necessary to do some degree of policy configuration there, just to kind of give us a starting point to work from. I suppose the other thing to kind of mention is that, obviously all of this is going to be something that we want to flag to a human at some stage so that it can be reviewed. There will be the occasional false positive, hopefully not too many, but hopefully it means that the useful information that's surfaced there is kind of immediately actionable and something that can be of immediate utility there. That's the goal, and that's the kind of problem it can solve. So reducing that configuration burden and hopefully improving the quality of the alerts that one receives. If
I'm a cybersecurity leader, I'm probably going to combine some machine learning with some policy and take a top-down, bottom-up approach, right? I might take a top-down approach of, I know I need to protect certain data from leaving my organization, and as such, I'm going to write policies for that. I'm going to go out and say, if I see it leaving these egress vectors, stop it, redirect it, let somebody know. And then that's my low-hanging fruit. That's my immediate risk reduction. And then I'm probably going to layer in the bottom-up approach with machine learning to say, show me across all of this amazing visibility, because it's got to be good data in if the machine learning is going to be functional, right? If I get bad data in, I'm going to get bad machine learning detections. But show me all of this great visibility in practice and show me risk that bubbles up from the bottom, and then let me decide whether I want to do something about it or not. That decision factor, that bottoms up approach. I think if I'm a cybersecurity leader, I think that's how I'm approaching my data protection practice.
No one knows what data is important to your organization better than the organization itself. So there's always going to be a place for traditional policy configuration, but machine learning is another tool in your toolbox that will help you find those things that you maybe haven't thought of in advance.
That's a perfect conclusion, right?
One of the other things you said there, Troy, that was quite interesting, that is kind of, I think, worth teasing out a little bit more, is the importance of the data into these algorithms and how accurate and how clean that is. So as we were sort of talking about before, these techniques are designed to tease out patterns and signals inside large volumes of data, but they do that best when that data is of high quality in the first place. And if you put in a lot of low quality data with a lot of false positives or errors in it, then it's just as likely that they'll find those errors as patterns inside that data. You know, it's the computer is still just performing the tasks that it's assigned. It doesn't really know what is correct in these situations. So that comes back to the quality of an existing solution here. And if you're looking at or evaluating different products that are doing machine learning, then looking at their event data, looking at how clean that is, looking at whether it has lots of false positives in it. And if someone is trying to sell you this idea of like, well, we can take all that and put it in machine learning and that'll clean it all up and fix it all, I would be a little suspicious of that line of reasoning. Let's just
still not a silver bullet for the cybersecurity professional. There's still no silver bullet out there that fixes all my problems.
Sadly, not. We're working on it. That's coming.
Well, Alan, I think I'll stop here and say, hey, thank you so much for joining me today and having a cup of coffee with me across the pond, right? I should say the power of technology is pretty amazing. You're over in the UK and I'm here in the US today, but thank you so much. I've learned a lot. I appreciate you sharing your knowledge with me. I think the machine learning is something that we're going to continue to hear in the news. We're going to continue to hear buzzwords around, and there's going to be confusion around it. But I think in our world, if I were to summarize up what is machine learning to us in a single sentence, it's the ability to take this wonderful set of visibility and raise risky behavior to the security professional so that it doesn't become a problem down the road. It's what don't I know is going on? What don't I know? What hasn't been bubbled up and how do I get that there? And I think still, if we focus on that and use the machine learning for those purposes, that top down, bottom up approach, I think we get to a much more secure organization. So thank you for joining me today. And thanks for everybody for tuning in. Feel free to reach out if you want to talk more about it. I think my contact information and maybe even Alan's will be posted out there somewhere. So thanks for joining me.